We're looking at the grade 11 November 2015 chemistry paper, and it's a question on acids and bases. The first question, define an acid in terms of the Lowry-Bronsted theory. And we know that according to Lowry-Bronsted, an acid is a proton donor. Write down the formula of the conjugate base of HSO4-. Now, if HSO4- has a conjugate base, that would make HSO4- an acid, because every acid has a conjugate base. And if it's an acid, that means it would be a proton donor. So when HSO4- donates its proton, it loses a proton, and remember, the hydrogen H plus ion is a proton, then we would end up with SO4 2- ion. So that would mean that HSO4- is the acid, and the conjugate base of this acid is SO4 2-. So every acid becomes its own conjugate base after it has donated a proton. They now ask us for the conjugate acid of HSO4-, and we would follow the same steps. If it has a conjugate acid, that means itself has to be a base. And according to Lowry-Bronsted, a base is a proton acceptor. So HSO4- is going to accept a proton. So it's going to become H2SO4. So this would be the base, and the conjugate acid would be what it becomes after it accepts a proton. And that is how we get the conjugate acid-base pairs. They also want us to give them a substance that acts as an ampholyte in these reactions. Now we know that an ampholyte is a substance that can act as an acid or a base. And because they had actually shown us in the previous two reactions, they'd shown us that HSO4- can behave as an acid and HSO4- can behave as a base. So HSO4- would be an ampholyte. And there's also another common ampholyte here, H2O, which we notice. So either one of those would be correct. The next question, a few drops of bromothymol blue indicator are added to potassium hydroxide solution. We know that potassium is K+, and the hydroxide ion is OH-. So the formula for potassium hydroxide is KOH. It is added to a dilute sulfuric acid solution, and we know that sulfuric acid is H2SO4. So a dilute sulfuric acid solution is now gradually added to this solution until the color of the solution changes. And we know that the color of a solution would change, the color of the indicator would change when neutralization has been reached. And we can see here that we've got an acid, sulfuric acid, and we know that all our hydroxides are bases. So this is an acid-base reaction. And we know that acid-base reactions are neutralization reactions. And that is why the color of the indicator changes, to show us that endpoint has been reached, that a point has been reached where the base is being neutralized by the acid, or the acid is being neutralized by the base. So the first question, the type of reaction that takes place, it is neutralization. And we would realize this because we can see that it is an acid reacting with a base. Notice that they don't tell us it's an acid reacting with a base, but we had to know that sulfuric acid is an acid, and potassium hydroxide and all our hydroxides are bases. On that note, even carbonates take place in neutralization reactions when they react with acids. They now want a balanced equation for the reaction that takes place. So we said we started off with potassium hydroxide, KOH, plus sulfuric acid, H2SO4. And we know that if we have an acid reacting with a base, our products are always a salt plus water. And that is going to help us to get this balanced reaction. And the salt that we would get here is a salt of sulfate. And we know the sulfate is SO4 2- ion. And we've got potassium, which is K+. So potassium sulfate would form. And the formula for this would be K2SO4, because the sulfate ion is -2 and potassium is positive, so we would need 2 of the potassium to balance that formula. And there would be 3 marks for that. And the last mark for the balancing, which we haven't yet done. We can see here we've got K2SO4, so I would need an extra K on this side, so we put a 2 in front of the KOH. Remember, when balancing equations, we are only allowed to add a number in front of the molecule. So now we've got 2 potassiums on either side. We've got 2 hydrogens plus another 2 hydrogens, that is 4 hydrogens. So to make this 4, we would put a 2 in front of H2O as well. So the hydrogens are now balanced. We've got 2 oxygens on the right hand side as well. We've got a sulfate on the left hand side and sulfate on the right hand side, and the equation is now balanced. They also want us to now tell them the color change of the indicator. So we need to have some information on our indicators. And bromothymol blue, it is a very popular indicator that is used in the lab. Bromothymol blue in an acid, it is yellow, and in a base, it is blue. So initially they had added a few drops bromothymol blue to potassium hydroxide. So that means that the initial color was blue because it was in a base, it was in KOH. And then an acid was added, and slowly it undergoes a color change until it changes to yellow. And then they ask us to name the salt formed in this reaction, and our salt is potassium sulfate. I hope you found this video helpful. Like if you did, subscribe so that you don't miss future videos, and share this video so that more people can benefit from these lessons.